Hello everyone, welcome back to the daily lead code practice session. And let me share my screen with you. Okay. The first problem today from the easy bucket is long first name. So the crux of the problem is you are given two strings. One is the actual name of a person and one is the typed whatever he has typed on the keyboard. Now we have certain constraints on this is like if a person types a character on the keyboard, it may be printed once or multiple number of times. Okay. Now, given the actual name of the person and what he has typed, we have to just tell whether he actually wanted to type his name and which because of suppose some error in the keyboard got printed differently. So like in this case, the name of the person is Alex, and based on his typing, he can we can see there's a double A, then L, then double E and X. So we can see that he's trying to type Alex, but because of the keyboard error, it got A got printed twice and E got printed twice. Similarly, if we have the name as Said, and we see try to map the typed words into the actual name, we can see S got printed twice, and then we had A, and then so on and so forth. So we just have to find out whether the typed word is actually something which he was trying to write it for his own name. Does the problem make sense?
Yes.
Okay. Approaches, suggestions, methods. Anyone has solved this problem already?
Let me see. I tried this one using two pointer. So the first pointer point to string, the first string, and the second pointer point to the second string.
Okay.
Okay, and if they match, and then I move to the next pointer, and if the next pointer of the first string is different than the next pointer of the second string, then I see if the pointer of the second string is same as the previous pointer of the first string, and if they're the same, I keep moving forward.
Okay.
And I just repeated it until like all the we process all the character on both string.
Okay, so let me share my screen, probably whiteboard, and then we can try to simulate what you're saying. So here's the first one, S-A-E-E-T, and the other one that I can see is S-S-A-E-E-T, right? Something S-S-A-E-D-D, sorry. Let's suppose this is your first pointer and this is your second pointer.
Yes. So now they are the same, and then I advance both pointer
to next ones.
Okay. So now they different. Then I see if the pointer on the second string is same as the previous pointer of the first string. So in this case, S is same as S. So I advance the next pointer on the second string.
Okay.
Now I do similar check. They both pointer are the same right now. So I advance both pointer.
Okay, so you will advance this pointer as well as this pointer one step forward. Right?
Yes.
Okay. What next? Then we'll
So
move
now,
forward.
now, yeah, now they are both the same. So I advance both pointer again.
Okay, so both of them are same. We'll advance both of them.
Yes. So now E, they are not the same. E and D are not the same. So I look at if D the same as a previous pointer of the first one. So D in this case, it's not the same as E. So I fail this case.
Okay, so yes. Okay, yeah, I think this will make sense. Yeah. So essentially what we are doing is scanning the second one and anything which is redundant, just removing, ignoring that and moving forward.
Yes.
Which is not going to be mapped. Oh,
yes.
Makes sense. So what I did was similar to this, but in a different way. So what I did, I used both of the strings and I just moved forward and counted the number of continuous ones. Suppose this is s equal to 1 and here I have continuous s equal to 2. Right? So this one and this one, the first one has less number of s, so it's definitely achievable. Next, I move ahead and see how many continuous a's are there, because that's the next character in the initial one. And if it is same or greater than the next one, it is still possible. Next, I move to the next one, which is E. Here there are two E's, but then I have only one E here. So then this condition fails because I cannot satisfy the condition of both the E's present from the actual name into the type string.
Okay.
So that's where I stop the matching. And if I'm able to match all the elements, so suppose there's only one E, I'll move forward and I'll see 1D and then I'll see 2D and my initial string has already completed. That means I'm able to get the name from this, the type characters here are actually this one. Does that make sense?
Yes. So you count the number of current character and
right.
compare. Yeah. Okay.
Any questions on this approach or the approach which was discussed before this one? Guys, anything? If no, we can move on to the next question.
One quick thing, actually, is there any other approach besides the two-pointer approach per se?
I'm not sure. Like, so these are two approaches that we discussed, and I only have gone through these two from the.
But even your approach is also kind of like the two-pointer approach, right? I mean, you're doing the same thing, moving around.
Yeah, the same thing, but just in a different way. Instead of doing it one by one, I'm just taking bunch and all of them in a bunch.
Okay, can we quickly talk about the time and the space complexity of the algorithm?
Yeah, sure. So the time complexity of this will be O of the length of first one plus length of second, which essentially comes down to whatever is the maximum of this one. O of max of L, M, just assuming L and M are the two different strings, length of the two different strings.
And the space would be O of 1?
Space is constant because I'm just using two variables, which will store the count of constant variables. Now, like in this case, it would be 1 and this would be 2.
Got it. And this is actually a very classic problem. Like, if you look at two-pointer approach, trying to merge sorted arrays and things like that, this technique is very, very common. So if you haven't coded this up, I would actually strongly encourage folks to code it up. there are quite a lot of edge cases that you will actually run into. Like, one of the strings is null. What if the previous character is this? And there's a bunch of different things. Just make sure that you have the right pieces in place. There are, I don't know if I kind of slipped out a little, but I don't know if you talked about a scenario where you could have duplicates in the first string itself. Like, there could be like 3 S's in the first one. And
yeah, we discussed that. We had initial one had SAEED. This was
there you go, right? You just have to make sure that that is like that is specifically covered, and it's very easy to trip up and not handle that scenario. So making sure that you're designing the test cases for this is important. Otherwise, I think it's a very, very simple question. The problem solving of it is very straightforward. Coding should be very straightforward if you know what you're doing. So if you haven't written it, please write the code and then share it in the team chat. In the class.
Yeah. Okay, can we move on to the next one?
I think we're ready to move on to the next question. Go ahead.
Okay. Initial string again. Okay. Yeah, the next question from the median bucket, it contains duplicates. So what it says is you're given an array. You are given 2 integers, k and t. So k is kind of a window where you have to scan for the duplicates, and t is the difference. So it's essentially not duplicates as such, but it is nearest duplicate. Like what is the value which is within the window of t. So what it says is you have to find 2 numbers, num of I and num of j. Okay, and the absolute difference between those two should be at most t. Okay, and these 2 numbers should be within the window of I and j. Okay, and their absolute difference should also be at most k. So there are 2 variables. Just take note of the variable. One is t and one is k. And k represents the difference, absolute difference of the indexes, whereas t represents the absolute difference between the values. Is the problem clear?
Yes.
For everyone? I hope it's clear for everyone.
Yes.
Okay. Anyone has already solved it? Or has any approach for this one?
One approach I take is like you mentioned, right? For every window, I'm searching for absolute value of t. So in case of the example 1, I have the window of 3. So I scan every window and search for, is there any element within that window? The absolute value is less than or equal t.
Okay. That's kind of a brute force approach, right? So
yes.
Taking every window and then trying to find whether there's an element which is having absolute ST, right?
Right.
Okay, any other approach? Anything else, like any other data structure we can use?
I think I could use a map.
Mm-hmm.
Yeah. The map is to put the Windows number to that map. If the user map, and at the same time I use 2 pointer. Yeah, one pointer is iterate the whole array, and another pointer is point to the left start of the window. if the window size is larger than k, the map erase the number out of the window, and we will find the lower bound of the difference in that window. If it less or equal than t, that return true. Yeah, or else we will return false.
So you're saying you will take a window of size k and then create a tree map out of it?
Use 2-pointer to create the window and record each number of that window, put the element in that window to the map. Yeah, when we iterate the
and
array.
Then,
yeah,
and then how will you use tree map? Like you suppose you have a window. Let's take, let me share my screen.
In that case,
So suppose this is the input, right?
Yeah.
And our window size is 2. So my first window will be suppose 1 and 5, right?
Yeah.
And what will I do next?
And we use a for loop to iterate the whole array. Like we use a pointer I to iterate the whole array, and we use another pointer j to
so
point.
Loop, you loop from 1, 5, 9, 1, 5, and 9, right? You loop over all the elements and find, what will you find here?
At the same time, the j pointed to the 0 index 1, and when the I minus j larger than k, we will erase the map, the element 1. That means keep the window only contains two elements. Yeah, move the window.
Got it. So your first tree map will contain elements 1 and 5, and then it will contain 5 and 9, right?
Yes.
But my question is, how will you find whether there's another number which will give you a absolute of a minus b equal to or less than equal to 2 in this case, right?
Yeah, we use a map to record the index of the element, like the M1 is equal 0, M2, M5 equals 1. We save the index of each element.
0 and 1, and this is 1 and 2, right?
Yes. And I use the low bound.
You use lower bound?
Yeah, lower bound. Numbers I minus t.
I minus t.
Yeah, that will find the lower bound of the difference between each element with the t.
This I is the index of the current element or the value?
The I is the index of the array, the pointer to iterate the whole array. The I is the pointer to point of the window right. Yeah, the J is a pointer to the left window, and the I point to the right window. Yeah, that I is the index. And if the lower bound is found, and the absolute value between the A of the first, let the A variable equals M lower bound numbers I minus t, and if the A iterator.
But there's one question. Yeah. You have I as index and t as the absolute value of absolute difference of values.
Numbers I, not only I. Numbers
okay. Let's say I.
Yeah, yeah, yeah. And if the iterator is found, and the absolute between the key of the iterator and numbers I and less than or equal than t, then we return true.
Okay, so let's assume you have a value of t equal to 3. And suppose your a of I, that what you are looking for is suppose 4, right? Then you are trying to find whether you have 4 minus 3 equal to 1, which is equal to 1 in your already right. That's right, right?
Yeah.
Now suppose your a of I is minus 4.
Then that means we find the one that that one is maps iterator. The maps iterator has 2 elements. The first element is the key. The key is the value of the element, and the second is the index. So we can use that iterator to get the value of the element and minus the numbers I, the AI. That means we find the difference between 2 elements. If this if the difference is less or equal than t, that means we can return the true.
Just one thing, I'm not sure what lower bound does in C++. Does it give the value which is the greater value which is lowest, or the lower value which is highest?
Yeah, it's equal or larger than the target value.
Equal or larger. Okay. So let's assume you're trying to find this one, a of I, suppose equal to 4 plus 4, right? Now you are trying to find whether 1 or 5 is there, right?
Yes.
And sorry, 1 value, and then you have elements as 5 and 10, right?
Yeah. You mean AI is 4 and the target value is 3?
3.
Yeah. And the difference of AI minus t is 1. Yeah.
Right. And then suppose in your tree map you have values 5 and 10, and the lower bound will give this value, right?
Yeah. Yeah.
Right. And suppose, and then you get 5, then 5 5 minus 3 is equal to 2, right? Now let's assume we have 15 and 20. What will happen then? We'll get 15 minus 3, which is 12, right? Which is not within the range.
Yeah, if it's not in the range, we can go to the next window. And once we find the difference is less or equal than t, we will return.
But then we are missing one point. So we have to look at the absolute value. So for absolute values, it can come from a positive side or a negative side. So if we consider mod of a minus b equal to, or let's say a minus b equal to c, then we have actually 2 equations here, not just one. So we have a minus b can be equal to c, or b minus a can be equal to c, right? Because mod will convert both of them into a single value. So we cannot just look at one side, a minus b. We'll have to look at the other side also.
We just put the difference between the like is the example 15 minus 3 equals 12. We put the absolute value of the difference between 2 elements, and we can solve this situation.
So suppose your array has these 2 elements, minus 2 and plus 15.
Yeah.
Right? And again, the same things. We have 4, then we have 3 as t, current element is 4. So this is your original state. And now the elements in the tree are these 2. Right? You'll take 4 minus 3 is 1. And then your floor or the lower bound will be 15, which is not within the bounds, right? but actually you do have one element which is -2. Okay.
Yeah, the lower bound will find the element larger or equal than than your target number. So if you are looking for the lower bound of 1, the the iterate will return the next element to -2, because -2 is less than 1, and the iterate will point to the next one, like in your example is 15 here.
Okay, but what I'm saying is, according to your logic, you will see to the 15, and then 15 will not give you that target of 3, right? So you will move ahead and go, move your window to the next element, right?
Yeah.
And then you're missing one of the element which can give you a target value, -2.
Yeah, next window means we move to the 5, 9 window.
Yeah, let's assume these are the 3 numbers, -2, 15, and 10, right?
Here? Yeah.
And if you are looking for AI equal to 4 with target equal to 3, right? Or target equal to 6, let's say it's 6, we can make it bigger. Now your target, you're looking for 4, 6 minus 2 is 2, right?
6 minus 2, 4. Yeah. 6 minus 4 equals 2.
6 minus 4 is 2. You're looking for 2. And then what you'll get from lower bound is 15.
Yeah.
Right? And 15 minus 4 is not within the bounds of a requirement. It is greater than 6. Right? But there is another element like -2. If we do -2 minus 4, it will give us the range which is 6. Right? We'll miss this element. We just have to find whether there is one more pair or not. And if you move ahead with this one, your window will change and you lose this number forever.
Yeah. Yeah, maybe I think.
Yeah, so I'll just clear it. So your approach was right, but there's only just one caveat. So coming back to the original equation, mod of A minus B equal to C, right? This is the original equation. Now let's assume this is our T. This is our target. This is our num of I, or the known number. And this is what we have to find out from, like in your problem, it's from the tree map. Right? This is what we have to find in tree map. Now coming to, this can be actually converted into 2 equations, like A minus B equal to C and B minus A equal to C. Right? Because of the mod, both of the, because of the mod, they will both convert to C. Does it make sense? And let me write it into the equation of num minus search element equal to C, or num, search element minus num equal to C, which will give us what we have to search for is, one is num minus C, and the other element to search for is C plus num. Right? There are 2 values. So let me give you an example. Like suppose I have A equal to 3, target equal to 2. So to get A minus T, or let me A minus B equal to some value T, which is here 2, I can have 2 types of values, like 3 minus 1 will give me a mod value of 2, right? Or I can do 3 minus, or rather, let me do it reverse way. 5 minus 3 is also equal to 2. Can we now relate this into something like this one? So any value between this and this, if you take any value between these two, you will get this equation satisfied. Let's like 2, right? 3 minus 2 mod is equal to 1. Let's take 4. 3 minus 4 is equal to, if you do a mod, it will still be 1. And it is less than 2. So these will give you the two bounds, these two numbers, 5 and 1, where you need to find any number such that the equation is satisfied. Does it make sense? Or should I take another example?
I can add a like non-technical way to look at it. What we are trying to do, maybe that will help to think in that direction. So the first approach, which we were given, that we had a window and we were trying to go and look at each elements to make a decision. And that was a workable solution, but not good enough. So now we are trying to, get better. For example, suppose you are given a height of 10 guys in a sorted order, like, from minimum to maximum. And there is a new candidate. You want to pair that candidate with a guy so that, like, their height difference is minimum. So they will look less odd if they go outside, for example. I'm just making up an example. So what will you do? It's sorted. You will try to find a person of almost equal height or equal height. Suppose you found that point when they are standing, only the person on the left or right is going to make decision for you, because persons on the extreme left or the extreme right, they are not going to be paired up. Does that make sense? Because if you just, like, find something in middle, like, something which has just smaller than it or equal to it, if possible, then it's fine, or just greater than this, you will find the absolute height difference between those guys and you will pair up the candidate. And that is what exactly we are doing it here. Like, that's a non-technical way to look at it. Does that make sense?
So in terms of what Roger is saying, we are just here trying to find out if we don't take in terms of the height. So this guy has a height of suppose 3 feet, and we are trying to find other folks in the array or team such that the height difference between those two will just be at max 2. So if I have my height as 3 and there's a guy who's a height 1, which is just lesser than me, I'll still be able to achieve this. And if there's a high person who's taller than me, I'll still be able to achieve this. And anyone who falls in between these two numbers, I'll still be able to satisfy the equation, because these are my two extremes. If I go anything below that, my number will start becoming greater than 2. And if I go anything greater than this one, my number will again start going up, right? So it's like an equation where you have to find the two bounds after which your numbers increase. And these numbers will, not be in your data plot range.
I think everyone understands already, I guess. That's why there is no question, I think. Maybe.
Either it is clearly understood or it is clearly not understood.
Yeah.
Guys, if we have any questions.
Yeah, please ask questions if it is not clear, or if it is clear, then good. We'll move.
Yeah, looks good.
Okay, let's move on to the next one then. Okay, moving to the final question for today, which is from the hard bucket. So here's the problem. So the problem is longest chunk palindrome decomposition. The name sounds very intriguing. The problem is a bit simpler than its name. So you have to find the largest K. So K is the length of some groups that you have to create, and the groups in concatenation should return the entire text that has been given as the input. But the condition for creating those groups is your groups, suppose the first group should be same as the last group. And if we move ahead with the second group, it should be same as the second last group. Okay. And then we have to find out how many groups, the maximum number of groups can we create. Let's take this example. So here we have this string GHI something something, and it's a long string. And we can break it into 7 groups. The first group, you see GHI is same as the last group GHI. Then the second group, A, B, C, D, E, F is same as the second last group. And that, we can move ahead with the same approach, and then we'll find something if we have nothing splitted, a common between. So if you consider this from the palindrome point of view, each word or group of, these number of groups, and each group in itself will create a palindrome. Let's represent this GHI as A. So you have first and last character as A, then you have B and B, then you have C and C, and there's a D in between. Okay. So instead of a single character for finding palindrome, we have to find a group of word that will create a palindrome, and the length of this palindrome has to be maximum. Is the problem statement clear?
Yes.
Yep.
Okay. Anyone tried this already? Or any ideas for this one?
Yeah, I did it.
Right.
So what I did is take 2 pointers. One is starting from the very left, pointing it to the first G, and one point to the right, extreme right, and start comparing both. So I will not move my left pointer unless I find a character which is matching to my left pointer. So I move only right pointer toward the left. So once I get G is equal to G, now I already have stored my right limit, how far I can move my right pointer before starting my right pointer traversal. So I need to move right pointer to the right limit, which is pointing to my I when I started my traversal. So basically I'm just checking if GHI is equal to GHI. If yes, then when I start traversal of right pointer, like if I get a comparison G is equal to G, I also need to have a pointer which is where I need to reset my right pointer after I find the comparison or after I fail in my comparison. So that the next right pointer of my traversal will point to F. So basically I will start comparing. If I pass, I need to move my right pointer to F and left pointer to A. And if I fail, I will keep my left pointer at G only. That will be a reset pointer, and continue reducing the value of right pointer.
And tell what can you reduce your right pointer?
So let's say if I take the same example, GHI ABC1. So my left pointer will be at G, right pointer at I. I will have a left reset pointer, which will be also pointing to my G. I will have a right limit pointer, which will be pointing to I.
Okay.
So now I start my traversal, and I also need a next pointer in case I find a comparison like my left string, like GHI is equal to GHI, where I should start comparing A to. So my A will start comparing to F now after I find that comparison, right?
Let's assume this as a input string.
Small example. Okay.
I'm just trying to do So you have your left pointer here, right?
At G, yeah.
and then you start from the right, and then to try to find the G.
Yeah.
Correct?
So my G is equal to G. Now I also have a left reset pointer in case I fail in my comparison, where my left pointer come back to.
Okay. So this is your okay. So it's a saved index where you can come back if the comparison fails.
If my comparison fail. And
Now you have G,
the
H.
criteria for comparison fail is like I not able to reach to the right limit. My right limit is pointing to C from where I started.
Correct. So now let's assume there's Q here.
Yeah.
And then you start from G. Okay. Let's reset. And then you find a G here, right?
Yeah.
And you'll start comparing it again. You know, start from here and this.
Yeah.
So my question was, is it really useful to look at G, which is here? Will you ever find a starting string and ending string which is having same, just cross the halfway mark?
Yeah. Not required actually.
I'm just trying to your approach. It's okay. It's fine. I'm just saying you can probably optimize it a bit further by not looking anything which is beyond your n/2 mark.
Yeah.
Right. And okay, what would be the time complexity for this approach?
I think currently it will be order of I'm doing n comparison and order of n square, but less than that because I'm not doing always all the comparisons. So if I'm starting comparing G to C and moving to the left, but I'm again doing everything. So n into n/2, I believe so. N square, it seems in the worst case, But I can optimize it. Yeah. What I did to optimize it is whenever I'm traversing from back, maybe I can store the string in the reverse order. That will help me in comparison instead of traversing back character by character to reduce the complexity. Yeah, but I was thinking of I mean taking no space, so that's why. Yeah.
For example, you write on the board. What's the return result of this example? I think it should be 1.
Yeah.
For this one?
Yeah, this one.
Yeah, it is 1.
Okay.
Yeah, any other approach? Any other suggestions? If we can do better than n squared.
My approach is O of n. I just use one pointer I to iterate the whole string. Yeah, and I also have two string. One is the first, one is the last.
Okay.
First string and last string, and I use the for loop to iterate the whole string. Yeah, and the first string equals first plus this is test I. Yes, test I. And the last string equals text n-1 minus I plus last.
Okay.
Yes. Yeah, and we use the if condition. If the first equals last, that means we found the same string at the beginning of the test and at the last of the text. So we will aggregate the return result at 1.
And what will be the aggregate value?
Yeah, aggregate, maybe we return the result or answer. We use a count to to count how many groups, how many palindrome groups in that text. Yeah, we aggregate the result, the count by 1. Yeah, if count. And at that time, we we update the first and the last to be an empty string. Yeah, this is also in the if condition. Yeah.
Yes, understood.
Yeah.
And then count is your result, right?
Yeah, we will. Yeah. And yeah.
You're doing it again for 0 to last element, right?
At the second for loop, the I will become to 1, 2, 3, and we get the string in the middle of the text, and we will compare on and on. Yeah, we
what I'm
start.
saying is, do you really need to go to the last element for I?
Yes. Go to the last element. I think.
Let's assume your I is here.
Yes. Go to the last element. Yes.
Let's take this example where your I is equal to, suppose that this in the 0, 1, 2, 3, 4, 5. Okay. So what will be your first? Your first will be equal to GH GI UB. And your last will be equal to C.
The last is not C, I think, because the last is aggregate from the CBU. Yeah, it's
That will be
CB.
HGIUBC, right? The 5 characters from the last.
Yes.
So coming to the same point which we were discussing earlier, if you have crossed the halfway mark, will you ever want to consider these two scenarios where the first and last are overlapping or crossing each other?
Yeah, that means in this situation, your last example will return 1 because there is no first and or last string equal to each other. So the last example return 1. Yeah, and we go to your current example. Is there 5A? Yeah, we can try. Yeah. And when I equals 0, there is no the first not equal last because first is B, last is A, and we go to the I equals 1, and the first equals BA, and the last equals BA, and we will get the count equals 1.
All right, so I was just checking if we can just go to the halfway mark and it will still do the work for us or not.
Yeah, I think we can go to the last. Yeah, we can try. Yeah, once we go to the I equals 0, 1, 2, 3, 4. Yeah, we also can get the correct answer.
Because we don't need to go after the half. Anyway, your first half will max be this one. Right? If you are not able to get first in the first half and then match it with something in the last,
yes,
it anyway is not going to be a palindromic number. Right?
Yeah, we just need to go to the half of the string. Yeah, half of the text. Yeah, when we go to the BAA, yeah, that's enough. Yeah, you're right. Yeah.
Has anyone tried this with the dynamic programming approach? I know when I looked at this problem, the first approach that came to my mind was the dynamic programming. if we have to do this with dynamic project programming, could someone, help us out, help me out with the reconciliation, or what will be the DP equation for this? I think we still have some time. Yeah, we have. There's any idea, any guesses on the DP approach? Sorry if someone had asked any question in the chat. Let me just check. There was a question related to KMP. Roger, would you like to cover that up? I'm not sure it was discussed about that.
Yeah, so since we are kind of doing pattern matching, I think the question was, at least what I could think about that, can we use KMP to do the pattern matching because it will be faster? And of course we can. I, at least for me, it is easier to come up with generating a hash using a number. And so I used a Rabin-Karp algorithm. As long as there is no collision, it is almost equally performant. So like, for example, in this case, for GHI, suppose you can assign each number G, H, and I a number, unique number, and you can generate a number based on that from going from left side to right side. Similarly, when you are generating number I, H, and G from the right side, and you can generate a hash in the similar manner, because now you have GHI, and you are just comparing those long or int, you are comparing two numbers. You can just you are not again doing anything with a string. You are now comparing numbers, so you will achieve the better time complexity of number of elements in that string. So that's the idea. Let me check. There are another comments here in the chat.
Yeah, I think what Munish was trying to say, if we can use the LCP array, LPS array that is created for KMP,
right?
This prefix array. One thing, Munish, I don't know if he's on the audio bridge, but one thing is, once you have found out the first, the smallest LCS on each side of the string, then you will have to do it again for the entire string, because LCS will give you a pattern, common prefix and suffix from starting until end point, right? Then you'll have to calculate it again based on the new, pending string. So suppose in this case, once we have out of GHI, then your remaining string will be this one. And then you'll have to again calculate that LCS for the LPS for the remaining string, right? That's what I think Roger was trying to say. It's better, easier to, or faster to calculate the hash, rolling hash, as compared to LCS array to calculate what we can move. And again, one more thing, LCS will give you the longest set, right? In this case, because we are trying to find it using a greedy approach, we want the shortest prefix and suffix match first, so that if there's a common string in between, that will create its own set and the numbers will increase, right? Does it make sense? Okay. Yeah, Roger, sir, go ahead if you are saying something.
No, I'm fine. I think I was so the Munish used to talk to us, because it's very we can't check the chat while we are working on the problems, and especially if you are on phone, we can't even look at it. So yeah, if you have questions, jump in, and then suggest we are always welcoming better suggestions. For me, I haven't coded KMP in a while, so it is possible to do it. I'm pretty sure because it is one of the fastest algorithm. But for me, like hashing is very natural. It's like math. So I can get that thing, working faster. It works in this case. So that's why I suggested that solution. But yeah, feel free to use KMP. Should work.
Yeah. So Manish, what Roger was saying, where we are actually, taking the strings one by one and then comparing where we could actually create a rolling hash, for the comparison point of view. That will be faster, and we don't have to actually every time take the substring and then compare, which is of n operation. Instead of that, what we can do is while we are iterating, we can create a rolling hash, uh, and that's part of the Robin Karp algorithm, which Roger was saying. And then once we find a hash match, then we can actually go ahead and try to see if the strings are actually same, because the hashes can be same, but the strings cannot, may not be because of the hash collisions.
I think he's asking, can you please iterate once for hash? Do you mean like, run a sample, like, how we would do it, how we will generate the number? If that is the question, I can try, like, working on the screen. But is that the question, first of all? Yes, or on a small string. Okay. So let's run it on GHI from both sides. Can you share the screen, Puneet? Let me try.
Are you, or should I screen?
Oh, you want to do that? Yeah. So let's have GHI, then write dot, dot, dot. GHI, dot, dot, we don't care. And then GHI. So from left side, when we are going, we have assigned each alphabet some number. Like, you can,
Roger, just one
yeah,
second. I just wanted to give it, a bit easier representation if we do
yeah.
it in numbers, like 1, 2, 3, and then dot, 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 and 1, 2, 3.
Okay.
So if we can just, that probably because then just the base is changing, right? This is a base 10 number, and this will be a base, suppose 26 if we are considering only
Mm-hmm.
small case numbers, right?
Right.
Okay. So if we are reading, there are two ways. There we are reading from left to right, and then we are reading from right to left.
Right.
Now here we have 1 as the first one, and there we have 3. Right. If we move one step ahead in both sides, so what we'll do is 1 into the base plus the next number,
Yeah.
right? And here what we'll do is take the number, whatever is the new,
Mm-hmm.
right?
Exactly.
Into base raised to power this index. Suppose in this case it's 1,
plus 3.
and then plus then 3.
Mm-hmm.
Right? In this case 2. So it will become here 12, and this one will become 20 plus 3, which is 23. Right? And then we do the same approach when we move one step ahead. 12 into 10 plus 3, which will give us 123. And same way here, right? 1 into 10 raised to power 2 plus whatever we got from the last step.
Exactly.
123, right? I am just doing it on integers because it's easier to understand. For this case, it's exactly same. The only difference is the base here is 10. It changes from 10 to 26 in this case because there are 26 characters. And the other thing is, because the powers for 26 can go very high, we usually convert them into some kind of modulo function so that the results are within the bucketing range of modulo, right? And that's why we're saying, if we still see hashes same, we still need to compare the strings afterwards.
Right.
I hope it is clear now.
Yes, it's clear. Great. Thanks, Puneet.
Okay. Okay. Um, Any other approach, anything, Roger, Vivek, from your side?
I think you wanted to share a dynamic programming approach. Do you want to go ahead or?
Oh, yeah. Let me just share the whiteboard. Yeah, anyone has any idea what we can do with the DP? Okay. So what we can do in this DP, I'll just pictorially represent it, and then probably we'll go ahead and try to create an equation out of it. So we have some string, okay, and then we have part of string for the start and end. Right, what we are doing right here is in this approach is we are trying to find the smallest one which is matching, correct? Right, and this approach we can do for everything. So it's not necessarily like we have GHI, here we have GHI. We can have another GHI here, like GHI and then GHI. This will also form a valid, the start to end combination matching, right? So what we can do is we can keep iterating over the array from left to right, okay, and trying to find what part of the start is matching or the prefix is matching with suffix, and then reiterate over the remaining part. Does it make sense? This we can do till we are able to just meet at the middle and there's no element left to recurse. Now, if you do this, you'll find that this is what I experienced when I did with the DP. I found that always the answer was when I had this smaller first element chosen. And then everything else was giving me lesser numbers because I was already reducing the numbers which could have been generated because of this and this, which are again the same, like GHI here, GHI here. Essentially, kind of recurrence relation becomes, if you have a function called function from I to j is equal to function of a comma b, and considering I to a is equal to b to j and 2 plus. Right, because the two are the numbers which are created when I'm considering here and here. And I can use a max function over all the numbers. And for faster approach, we can actually, cache the results from A to B, whatever is the, I to J, we can cache them so that we don't have to, calculate the same thing again and again. Does this make sense, the DP approach? I hope it is clear, guys. Okay, I'll assume everyone understood it.
Yeah, makes sense.
Okay. If we don't have anything else, I think we are almost in time today.
Yeah.
Anything else we want to discuss, guys? Anything, not just from this one, but anything else you want to discuss? I'll stop the recording for today and then we can continue discussion if we have anything. Thank you guys for